This video builds on the previous video where we did the zebra crossing using the Cytron Micropython RP2040 board, which has built-in LEDs, switches and motor drivers. This code is going to be for creating a four-way UK traffic light system, and it's just for basic demonstrations. It's going to use the 12 onboard LEDs to show it working, and I will possibly connect a couple of other LEDs using the outputs to drive an actual LED so you can see it working at the end. The code is written in Micropython using the Thony IDE. I'm going to start off by importing two library files. The first one is from a machine. I'm going to import pin. This gives me access to the input and output pins very easily. And I'm going to import utime, which will allow me to use the utime.sleep for delays. We are now going to create 12 variables. These will be used to identify the pins or the LEDs that we want to use. So as you can see here, we have red 1, amber 1, green 1, and these will be representing the different banks for each of the traffic light heads. You will see red 1 equals pin, and then open brackets 0, which dictates the GP pin used on the Pico as 0, and we're stating it's pin dot out, and then we close the function. We do this for the remaining 11 LED pins that we're going to use. The next few lines of code you see, which is red to A low, amber to A low, green to A low, and utime.sleep, I'm going to delete. They were there when I was originally setting up the code and are not really needed now. So I will just delete them from the code. For this sketch to work, I need 6 functions. These functions will all get called one at a time in the while loop at the end of the program. Each function is very basic, and it's using some of the pin library to either set the output pin as high or low. So as you can see, in the define step 1 function, we have red 1.high, amber 1.low, and so on until we get to the very bottom, which is when we use the utime.sleep 2, and in this case .sleep 2 is 2 seconds. Once it's reached the end of the utime.sleep, it will return to the while loop. The remaining 5 functions are all very similar, so I'm not really going to explain them because they are the same. But then we get to the while loop, and basically while true, it will keep looping through every one of the next 6 functions. So step 1 function, step 2 function, and so on to step 6. Obviously once it's completed step 6, it will return back to the top and start again at step 1 function. And that is how simple it can be done using the Raspberry Pi Pico RP2040. This code will work with an ordinary Pi Pico, but you would have to do all your connections, which sometimes is not as easy as using this type of board, which has got the built-in pins. To upload the code to the Raspberry Pi Pico, you need to first go to Tools, Options, and in the options you go to the interpreter, you make sure it's Micropython, Pico, and the USB port or COM port that you are using on your PC. You then go to File, Save As. You've got the option of saving it to your computer, or in our case we want to send it to the Raspberry Pi Pico. You have to save it as main.py, click OK. Do you want to overwrite install the original program that's on the Pico now. Click yes. And your new code is now up on your Raspberry Pi Pico RP2040. The video shows the LEDs attached. Unfortunately, the LEDs, the amber and the red, show up very similar. This I can't avoid at the moment, but hopefully you can see the system working as best I can demonstrate it on here.